Hello everyone. Greetings and welcome to our NLP lecture series. Today we will be delving into the world of chatbots. We will start our discussion with exploring their applications of the chatbot and learning how to build one from scratch. These chatbots are also known as conversational agents, which are revolutionizing the way the businesses interact with their customers. These chatbots have become increasingly popular in recent years, serving as a virtual assistants for customer services, education, healthcare, and entertainment. These are all just a few of the industries in which they are employed. So these AI powered assistants simulate the human conversation, enabling the users to get the information, making transactions, and receiving the support without human interventions. Moving on to this, any chatbot, whether it is the self-learning intelligent chatbot or the rule-based one, certain steps are common. So it all starts with the user message that initiate the conversation. The computer then interprets the user message, passing it through the intent classification or entity resolution. Both the steps will go on. This intent classification determines the user's intention behind the message, while entity resolution identifies any specific individuals, objects, places, or the types mentioned in the text. So these steps helps the chatbot to understand what the user is asking or talking about, enabling it to generate relevant responses. For example, if I start the conversation with my bot and type hi, the intent is that I'm initiating the conversation. However, if I were to type the message bye instead of hi, so my intent would be to end the conversation. So in this classification step, the chatbot evaluates the intent of the user's message. In the resolution step, the chatbot identifies any specific entities present in the sentence that the user has provided. Once the intent and entities are identified, the chatbot's AI brain, which is the core algorithm of the chatbot, which processes this information and selects the response with the highest similarity score to the input. So this response is then passed back to the user by the chatbot. This is the common operations of the steps while building any type of chatbots. Moving on to this, there are two different chatbots. If you look at the implementation methods, those are the fixed rule based chatbots and the ML machine learning or NLP based chatbots. If you come to the fixed rule based chatbots, in these chatbots you don't need any machine learning algorithms to be written. They operate based on the decision tree consisting of a set of if else statements. So the responses are predefined and triggered by the specific patterns or the keywords in the user input. Coming to the NLP chatbots, in these you have the option to use the framework or implement the custom solutions. Two methods or strategies are there. These chatbots use the natural language processing techniques to understand and generate the response to the user input. So the frameworks like the TensorFlow, PyTorch, NLTK will offer a pre-built tools that models our NLP tasks. This custom implementation involves building your own NLP models tailored to a specific requirement. For example, Amazon customer services, Netflix customer services, likewise. Tailored to a specific task. There we can use this one. Let's have a detail about this one. This rule based fine. This using this chatbot frameworks. This Google's Dialogflow is widely used framework for creating the chatbots, along with the Raza, IBM Watson Assistant, and Amazon Lex. So Microsoft Azure is also offering offers a platform for building the chatbots. These are all just a few among the hundreds of available frameworks, but Dialogflow, Raza, and IBM Watson are the particularly popular. For custom implementation, there are various approaches you can take. You can leverage APIs like the OpenAI to access the models such as the GPT and LLM. Additionally, there are open source language models like Hugging Face, but AWS also provides the foundational models that can be customized to fit your nodes. So these possibilities for customization are extensive when creating your own custom implementation. So now I'm going to demonstrate a simple self-learning chatbot which is written in the Python that respond to the user queries based on the information that it has learned from the text corpus. Fine. Yes. Coming to the demonstration part. So as we discussed, we are going to build a simple chatbot, is a self-learning chatbot based on the text corpus, the information what it is learned based on the text corpus, it is going to respond to the user queries. So for this, I need the data to be created. So my chatbot, I'm creating a chatbot which is going to respond to this text corpus based on the questions posted related to the concept of NLP, natural language processes. For creating this text data, what I'm doing is I'm taking the Wikipedia natural language processing task and taking a copy of this entire information and creating one notepad which will keep that information. A text document is created with the name of chatbot. We are creating and copy that entire content into this one and saved this documentation which is on the desktop. Now backing to this code, in the Google Colab, I'm just dragging that information from the documents desktop. We are using that chatbot and bringing the data file into this Google environment. Yes, chatbot.txt, and copy the file path and paste it here so that we will get that file is loaded into the Colab notebook. Right. So the first step is, so this part is been created. The first step is we need to import the required libraries. I'm going to work with the NLTK for processing this. I'm going to show you this, and the string is another library which we need for tokenization, not for the tokenization, for removing the punctuation marks, and the random I'm using for generating the random responses by the chatbot. Okay, after taking this required libraries, then with the loaded data set from the chat box created data, we are creating the document by opening the file in read mode and ignoring the errors. A raw document was created with this the data that was created. Now just have a look on how this raw document is looking. Yes, my main menu, Wikipedia, the free encyclopedia, this is the raw text which we had created. Once this is done, then we need to start the pre-processing. See, when you are working with the documents in NLP, we studied that the different pre-processing steps are there during the pipeline processing that we studied in our previous lectures. Lowering text to lowercase, converting the text into the lower cases, and then tokenizing into the sentences and words, and removing the punctuation marks, and also lemmatizing and generating the root words for the any words. All these things are the pre-processing. For doing all these things, what we did it here in this part of the code cell is, first we converted our raw document into the lower casing. Then along with that, for going on to the next step of sentence and word tokenization and further steps of lemmatization as well, I downloaded the required libraries, PunKT, WordNet. WordNet is for the lemmatization, and PunKT for this sentence tokenization, along with the supporting library OML. Once this is done, then using this sentence tokenization, our raw document was sentence tokenized and stored into the sentence tokens, and also the word tokenized and stored into the word tokens. Just let me run this code cell and see how it is. Now once the lower casing is done, after this I'm just showing how the raw document is looking like this. Yes, before the lowercasing, it was initial capital letters were there. Now, once it is processed with the lowercasing, entire is converted into the lower cases. And the sentence tokens and tokenization is also done. I just displayed 3 of the sentences, as we can see this here. This is one sentence, this is another sentence, and this is the third sentence. This is how the sentence tokenization is done. And just if you look at the word tokens, first 5 tokens, main, menu, Wikipedia, this is how the tokenization process is done. And the next step is we need to remove the punctuation, and also the lemmatization process is to be done. For these 2 steps, what we did it here is this line of the code initializes the wordnet lemmatizes from the NLTK library. NLTK.stem.wordnet. In a wordnet lemmatizer, lemmer was created. This lemmatization process is used for reducing the words to their base word at the root form. Then the next step is this function. Here we defined a function lem tokens, which takes the list of the tokens as input and returns the list of lemmatized tokens. It uses this wordnet lemmatizer lemmer, which is defined in the previous step. So once this is done, then this line of the code is creating a dictionary to remove the punctuations from the text. It maps each punctuation character to none using the Python's ORD function and a dictionary comprehension. So string.punctuation contains all the punctuations. From this, it is creating the dictionary called remove punctuations. Remove punctuations dictionary has been created. Once this is done, then this function lem normalize, this function normalizes takes the text as the string input, text string as the input, and performs the operations. What are the operations it is performing is, first it is lowercasing the text, converts the text into the lower cases, and removing the punctuations using this remove punctuation dictionary by translation process, and then normalize tokenizes the normalized into words. And now this lemmatizes the tokens using the previously defined lem tokens function. These are the steps that we performed in the text processing. The next is the most important, that is defining the greeting functions. Now, while creating the chatbot, we have to set the tone for the conversation and provides a more human-like interaction, which can improve the user engagement and satisfaction. It enhances the user experience by making the chatbot seem more conversational and friendly. So this code segment adds a basic greeting functionality to chatbot. When the user greets the chatbot with one of the specified phrases, the bot responds with the randomly selected getting responses. Okay, see, this greet inputs is the tuple containing the various greeting phrases, hi, hello, what's up, how are you, like this, which the chatbot will recognize. And greet responses is another tuple containing corresponding responses that the chatbot can give when greeted. Hi, hey there, there, likewise. This greet function, now this function takes the sentence as an input and it splits the sentence into the words and it reads over them. If any word in the input sentence matches one of the greeting phrases which are case sensitive, it randomly selects random.choice. It randomly selects the written responses from the greet responses, which is defined here. Clear? Okay. Now, this code is useful for building a simple response generation system based on the user's input. It allows the system to find the most similar sentences in a document and respond accordingly. By using the TF, IDF, and cosine similarity, it provides a measure of similarity between the user's input and the sentence in the document. It helps the chatbot to generate more contextually relevant responses. Now, this can be used in various chatbot applications where understanding the user queries and providing the appropriate responses based on the existing content is required. Okay, looking into this part of the code, the first we had imported the required libraries for doing the TF-IDF vectorization and cosine similarity from the sklearn library. About the TF-IDF vectorization, it was covered in the very beginning of the sessions in the NLP series that you can refer for a quick review of this TF-IDF vectorization concept. Now, in this function, first we started this robo response with the empty, and this line of the code, it uses the TF-IDF vectorizer of the scikit-learn to convert the collection of sentences into TF-IDF matrix. So first this lem normalize is used as the tokenizer, which normalizes and lemmatizes the words in each sentence, and the stop words are removed during the vectorization process. With this, the first TF-IDF vectorization was instantiated, and it was called by fitting on the sentence tokens. So that the TF-IDF vector dot fit underscore transform is called with the sentence tokens to generate the TF-IDF matrix. Now, once this is done, then it will calculate the cosine similarity between the TF-IDF of the vector of the last sentence, because this last sentence is the user input with all the other sentences in the document. Once the similarity was calculated, it finds the index with the ARG sort of this one, index of the sentence with the second highest similarity of the user input. Why we are taking the second highest similarity score is the first highest similarity one will be the user with the user input itself. So the second highest similarity score is chosen. Now it will return the index of the second highest similarity score from this TF-IDF matrix. Okay, once this is done, and the next step is this vals data flatten. This step flattens the similarity matrix vals into one-dimensional array, and this sorting helps to find the second highest score. So if this does the second highest score of this flattened values, the TF-IDF matrix is stored into the variable required TF-IDF. Now, if this required TF-IDF is 0, it means there is no significant similarity between the user's input and any sentences in the document. In this case, it returns a default response indicating the system, "I'm sorry, unable to understand you," to the user. Otherwise, it constructs the response by selecting the sentence with the second highest similarity score and returns it. This is how thus core brain of this chatbot was defined. A response system was defined. Now this code implements a basic chatbot that interacts with the user and by responding to the input text. Okay, now coming to this part, how the chat flow will go on. It starts with initialization of the greeting. "Hello, I am retrieval learning bot," and start type your text after greeting and talk to me. For ending the conversation, you just type "bye." This is how it has started the greeting. So that it starts by printing the greeting message and initialize the boolean variable true. Once done, then the next step is the chatbot waits for the user input after greeting and loops over. This will be converted into the lowercase and loops over this message and continuously wait for the user input until the user input is "bye." Okay, so now let's look at how this user input will be processed. User's input is converted first into the lowercase, which is for case sensitivity matching. Then if the user input is not by, then it proceeds to check if the user is thanking the bot by sending the messages thank you or thanks. If so, it responds appropriately and ends the conversation by saying you are welcome. Otherwise, it checks if the input is a greeting. If it is, the bot responds with the greeting using the greet function, greet of user response. If it is not greeting and not thank you, then it will go to this portion. Here what it will do is, the input is treated as a new sentence. So it is being appended to the sentence tokens. The sentence is tokenized and added to the list of tokens, and then words are added to the list of word tokens, and then it will start. The bot generates the response using the response function based on the user input. So this will continue, and if the user says bye, the loop ends and the bot says goodbye. So that this response code provides a basic framework for the conversational chatbot, and it allows the user to interact the chatbot by tapping the messages. The bot then responds to the user input with either the greeting or the response based on the similarity to existing sentences using TF, IDF and cosine similarity, or an acknowledgement if the user says thank you. Thus, it handles the conversation flow gracefully, allowing users to terminate the conversation by typing bye. This is how thus chatbot defined. Now let me run this code once again. I ran this code up to this part. Now the text processing is done, and the greeting function was defined, and the required libraries for this converting into the vector is done, and the chart flow was already and now I'm running this responses. Yes, it started the conversation. Hello, I'm the retrieval learning chatbot. Start typing your text after greeting and talk to me. For ending conversation, type bye. Okay, let me type this hi. Yeah, so it responded hi once again. So let me try another one. Hey, does it is? Yes, something is. This type of, sorry, I'm unable to convert it because thus the word, yes, greeting. So HEY, hey is not there in the greeting inputs. We have hello, hi, was up only. So as I texted the greeting input HEY, which is not there in the defined greeting inputs, it responded with I am sorry, unable to understand you. But anyhow, the conversation is going on. Okay, now I will give hello. Yes, it is continuing. The chart is continuing. Okay, now let me ask a question, because this chatbot had been trained on the NLP task from the Wikipedia information. Let us ask a question about automatic translation or something else. Neural NLP, one question. Text to given a text transforms. Yes, text to speech is the concept of given a text transform these units and produces the spoken responses. Okay, now I'll pose the question, what is a text to speech? So yes, in natural speech there are hardly any pauses between successive words. The speech segmentation is necessary subtask of speech recognition. Okay, we'll ask one more question. Tokenization is a process used to text analysis divided. What is tokenization? What is tokenization? Tokenization is a process used in text and that divides the text into individual words or the word fragments. Fine, it is giving good. And lemmatization. So about the lemmatization and the segmenting, reducing the inflected words, and about lemmatization. word segmentation, lemmatization, yes. Removing the flexional, okay. What is the lemmatization? What is lemmatization? So lemmatization is another technique for reducing words and their normalized form. How lemmatization different from stemming process? Stemming yields similar results as lemmatization but does so on grounds of rules, not a dictionary. Fine. So this is how it is going to respond. So you can do the conversation with this chatbot that you build on the whatever the NLP task about NER. You can ask the questions about NER. Okay. So what it is doing is whatever the query which is posted by the user, that will be added to the end as a end of token or the end of sentence to the entire set of sentences in the documentation, and will be processed according. Then the most similar sentence to the user query will be identified and will be written as the response by this chatbot. So to end the conversation, we supposed to give something what it is called the by. So it said, to stop the conversation, it said to say bye. So when I say bye, it responded with the goodbye and stop the conversation. So this is how to build a simple chatbot using NLTK.